In the previous class, already we have that one is the how to find the value of the determinant and what is the determinant is. That means determinant can be found from the square matrix, and then we are finding the value of the determinant in the expanded form. Expanded form means whatever we have done, that is in the expanded form. X into the minor and the cofactor, sorry, x into the cofactor, then the second element into the cofactor, in that way. Okay, now there are three properties. Already we have discussed. The first one property is when the determinant is transposed, the value remain unaltered. That's okay, unaltered. Why? Because the value of the determinant does not can be find out using the expanded form from any row or using any column. So when the row and column are interchanging, the value of the determinant is unaltered. That is the first one property. Second one, that is when the two rows or columns are interchanged. Any two interchanged, the value remains same, but the sign is altered. Sign is altered. Third one was if any two rows or columns have the same elements, then we have the value of the determinant as 0. Value of the determinant as 0. So those are the three properties we have already discussed in the previous class. Next one, we are proceeding to the scalar multiplication with the determinant. Now suppose we have a matrix. So when we are using the parenthesis way, so that means it is a matrix, no problem. Suppose we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and we are multiplying it with a scalar. What happens when we are multiplying any scalar with the matrix? Each and every element of the matrix is multiplied by the scalar. Okay, now that is the case of the matrix. Now when we are in the case of the determinant, so when we are in the case of the determinant, suppose we have a determinant. So when we are using using the notation that is the type of double bar or the modulus form, so that means it is a determinant. So 1, 2, 3, 4, 5, 6, and 7, 8, 9. Okay, then we are multiplying the determinant with a scalar, suppose that is x. What happens? So that is a scalar. Just remember, in the case of matrix, each and every element is multiplied. So it is becoming like x, 2x, 3x, 4x, 5x, 6x, 7x, 8x, 9x. But in the case of determinant, any row or any column is multiplied by the scalar only. That means not all the elements of one row or one column is multiplied. So it may be, suppose we are multiplying it with the first column. So it is becoming x, 4x, 7x. So the other two columns, that is 2, 5, 8, 3, 6, 9 remain unaltered. That is the first case. Or it may be like that. Suppose the first row is multiplied. So x, 2x, 3x, then 4, 5, 6, 7, 8, 9. So the second row and third row remain unaltered. Or it may be any other row or column. Suppose the third column. So it is becoming 1, 4, 7, first column unaltered, second column 2, 5, 8 unaltered, third column 3x, 6x, 9x. So that may be the case of determinant. Any row or any column, but only one row or one column. Suppose we have two scalars like that. Suppose x, y into, now the determinant same 1, 2, 3, 4, 5, 6, 7, 8, 9. At first, I am multiplying the scalar x. Any row or any column. Suppose I am considering the first row. So it is becoming x, 2x, 3x. Remain two rows are unaltered. Okay. So that is the first case when I am multiplying it. Suppose after that I am multiplying the y once again with the first row. So it may become xy, 2xy, 3xy, 4, 5, 6, 7, 8, 9. That is the one case. It may be another one. Suppose from here we are getting not the first row. The first row is multiplied with the x and I am multiplying the second column with the y. So it is becoming like x, 2x, 3x. At first, which one was 4, 5, 6, 7, 8, 9. Then I am multiplying the y with second column. So xy, 5y, 8y. It may be another case. Or another one, suppose we have like that. X, 2x, 3x, 4x, 4, 5, 6, 7, 8, 9. And after that, I am multiplying y with the second row. So there may be different type of cases, but always we have to remember whatever the scalar we are multiplying, that must be with only one row or one column. Now, most important thing, all the element, all the values of the determinants are same. That means that one is also equal to that one, also equal to that one. The black, the green, the blue, all the determinant have the same value. So that is the one thing of property. Next one, suppose we have another one determinant. As like we can multiply, we can also take the common, like 2, 4, 8, 3, 9, 12, 5, 10, 15, 20, suppose. Okay. So at first, check in the first row. In the first row, we have a common, that is 2. So we can take out the 2 from here as a multiplier. And first row is becoming 1, 2, 4. Okay. Now from the second one, we can find the 3 is a common. So we can write 3. So 3 taking out, and here 1, 3, 4. Same as in the third row, we can take out the 5 as a common. So that is 1, 2, 4. Now look at the row 1 and row 3. according to that determinant, as the two rows, row 1 and row 3, are equal, so its value is equal to 0. So the complete deterministic value is equal to value of the determinant is equal to 0 here. But that may not be the different case. In other cases, it may not be. But in that way also, we can take out the common from the elements of the determinant, and also we can multiply. But always we have to remember, suppose the same thing was a matrix 2, 4, 8, 3, 9, 12, 5, 10, 20. So that is a matrix. No element can be taken out because there is no common from each and every element. Is that okay yet now?
Yes, sir.
Yes,
Yes,
sir.
sir.
So
Yes.
Yes, sir.
next one property is very another one which we can use to find out the value of the determinants once again without expanding formula. 5. Suppose we have a determinant like a1 plus x, then b1, then c1, a2 plus y, b2, c2, then a3 plus z, b3, c3. Okay, look at the first column. The first column is just nothing. We have expanded. We have just expanded in a way. And expansion is using the plus sign. So we can use that one and decompose the total determinant. How? Let's check the determinant in the expansion form of two determinants. The column 2 and column 3 are remaining unchanged. So I am writing B1, B2, B3, C1, C2, C3, B1, B2, B3, C1, C2, C3. The first column is now like that: A1, A2, A3, X, Y, Z. That is the first type of expansion, or we can write out in that way. Now someone is suppose saying, sir, a1 plus x, suppose I am writing that one as x plus a1. Yes, very good, no problem. And I am writing that a3 plus z as z plus a3. So can we decompose? Yes, in the same way. Here the determinant would be like that: x, a2, z, then b1, b2, b3, c1, c2, c3. No problem. Plus a1, y, a2, b1, b2, b3, c1, c2, c3.
স্যার A3 হবে ওখানে।
A3 হবে, right? So that is A3. Okay. So in that way also we can decompose. Let us check with another one. Suppose a determinant has been given like that: 7, 5, 4, 9, 7, 2, and that one 11, 9, 5. Suppose. So we can write the first 7 as in that way, that is 2 plus 5, second one 2 plus 7, that one 2 plus 9. Okay, then 5, 7, 9, 4, 2, 5. Okay, then we can decompose in that way: 2, 2, 2, 5, 7, 9, 4, 2, 5, plus then 5, 7, 9, 5, 7, 9, 4, 2, 5. Now look at the first column and second column. Both have equal elements. So the value is 0, the deterministic value. So that one is now becoming only 2, 2, 2, 5, 7, 9, 4, 2, 5. Okay. Now once again in the first column we have all the elements are 2. So that means we can take the common as 2. So 1, 1, 1, 5, 7, 9, 4, 2, 5. Suppose once again we want to decompose. Once again. So we may proceed in that way. 2, 1, 1, 1. And here, suppose the second column I am decomposing. That is 4 plus 1, 7 plus, 6 plus 1, 8 plus 1. That one 4, 2, 5. So at that moment, the decomposition is according to the second column. So we may write 2 in the outer, because when we are decomposing only that determinant. So the decomposition means the determinant itself. So the first one 1, 1, 1, 4, 6, 8, and 4, 2, 5 plus 1, 1, 1, 1, 1, 1, 4, 2, 5. Okay. In the same way, that is also equal to 0. So that one is becoming 2, 1, 1, 1, 4, 6, 8, 4, 2, 5. Now, moreover, we want to decompose once again. 2 into. So it can be right 1, 1, 1, 4 plus 0, 4 plus 2, 4 plus 4, 4, 2, 5. Okay. So that can be decomposed in that way. The first one 1, 1, 1, then 4, 4, 4, then 4, 2, 5
স্যার একটা কোশ্চেন আছে স্যার।
প্লাস আমি বলে দিই তারপর 1, 1, 1, 0, 2,
ওকে স্যার।
4, 4, 2, 5. Okay. Now look at this first one. The first one is there. We have 4, 4, 4. So we can write the very first one 4 into 1, 1, 1, 1, 1, 1, 4, 2, 5. Okay. Plus 1, 1, 1, 0, 2, 4, 4, 2, 5. Once again, these have the same value, that is 0, because all have. So the determinant is now 1, 1, 1, 0, 2, 4, 4, 2, 5. Now, whatever we have done, just according to an example, but the decomposition must be according to our problem. If we require, then we must decompose, otherwise not. I have just given here so much example of how we can decompose, how we can using the plus sign or the minus sign, using the case of column, but that is only the case of column. We are not using it using the row, that always we are using the column. The decomposition is happening. Moreover, we have also taken an example here. We can take common the scalar from the one row or one column as a common. So the first one property, transposing of any determinant give the value unaltered. Two rows or columns are interchanged with each other, value remains same, but the sign is altered. Third one, when the two rows or columns have the same elements in the determinant, the value is 0. Then the multiplication of the determinant with a scalar number, and that is only with one row or one column. Then the fifth one was the decomposition condition. Now the sixth property, and sixth property is we can do any type of row operations and any type of and any type of column operations with the determinant, even any type of scalar multiplication, any type of scalar multiplication, but the value of the determinant remain unaltered. Let's check what type of operations we can do. Any type of operations already we have seen. Okay, suppose the very first one determinant is a 3 cross 3 of order 3. Suppose 7, 9, 1, 2, 1, 5, 4, 1, minus 2. Okay, the first operation, suppose I am going to do, that is R3 plus 2R1. Why I have done that is nothing. Here just the giving the example, that's why. According to problem, the operation would be. Here I am just giving you an example. Now R3 plus 2R1, that means which one? The row 3 is becoming like that. The row 3 is now row 3 plus 2R1. So what is happening here? Let's check. The first row and second row not changing. So 7, 9, 1, first row. Second row 2, 1, 5, not changing. Change it in the third row. First one R3. R3 means the first element, that is 4. Very good. Then the plus 2 into R1. R1 means the row 1 element, that is 7. So that is the first one. Suppose we have done, that is the row 3, then the 2, then the 7. Okay, next one. Suppose we have row 3, so element was 1, plus then 2 into row 1, that is 9. So once again, that means row 3, then 2, then row 1 element, that is 9. Okay, so for the third element, that is there was row 3, that means minus 2, plus then 2 into row 3, sorry, row 1, that means 1. So once again, row 3, 2, and row 1. So whatever the result we are getting, check, that one is equal to first row remain unaltered, second row 2, 1, 5, third row 7 into 2, 14 plus 4, that is 18, 9 into 2, 18 plus 1, 19, and 2 minus 2, that is 0. That type of operation we have done, but that value and that value both are same. Both have the same value in the determinant. Okay, now except row 3, we can also do any operation with the column. Let's check with a very small determinant. Suppose we have a determinant that is 5, 6, 1, 3. Okay, now I am doing the operation, that is the column 1 is now I am changing with the column 1 plus a scalar, that is minus 1, with the C2. That means that one is becoming C1 is now C1 minus C2. Okay, so what is happening here? That is, second column is unchanged or unaltered. First column, column 1 minus column 2. So 5 minus 6. Column 1 minus column 2, 1 minus 3. So the result is minus 1, 6, minus 2, 3. Let's check what is the value of that one. That is minus 1 into 3 minus 6 into minus 2. So that means minus 3 plus 12. That means plus 9. Let's check what is the result of value of that determinant. 5 into 3 minus 6 into 1 or 15 minus 6 or plus 9. So both have the same value after the operation. So any type of operation we can do with that determinant. Some more examples would be there. Yet now, is it clear?
Yes, sir.
Yes.
So according to these 5 or 6 properties, when whatever the assignments we have given, we can follow these type of properties to solve the value. Okay. Suppose not always in the expanded form. Expanded form means whatever we are doing, not in the expanded form. In the problem or in the question, it may be possible that you have written that not using the expansion or not using the determinant expanded form, find the value of the determinant. Then what to do? That is not always possible that the expansion is completely omitted. At least one expansion is required. But before that, using the properties, we have to minimize the determinant. Let's check, suppose that problem. We have a determinant that is x, y, 1, x square, y square, 1, x cube, y cube, 1. Have anyone taken the attendance? Okay, send it, huh?
Yes, sir. I have taken.
Okay, just send it. Now the first one,
Okay, sir.
suppose we are looking at the first column. First column is x, x square, x cube. So there is one element that is common, that is x. So we are taking at first the x common from the first column. So 1 x, x square. Okay. Same as look at the second column. There is one element that is common, that is y. So we may take common 1 y, y square. And finally, we have a 1, 1, 1, the third column. So that is the first one we have taken common. So here we are doing nothing extra, that writing that one, x, y. Okay. Now we are doing an operation. Operation means like the previous one. Suppose column 1, I am changing column 1 to column 1 minus column 2. Okay, so what happens? Column 1, 1 minus 1, x minus y, x square minus y square. Then the second column remain the same, third column remain the same. Okay, proceeding with the first column at that moment. 1 minus 1, 0, x minus y, that one, x square minus y square, that means a square minus b square, a plus b into a minus b. So that can be written as x plus y into x minus y. So the second column remain the same, 1, 1, 1. Now look at the first column. There is another element that is common. that is x minus y. So I am taking common x minus y from the first column. So now the first column is 0, 1, x plus y. Second column remain the same, 1, 1, 1. Okay. Now another operation. Another operation means here we can use the second column, that is C2. C2 is now suppose C2 minus C3, column 2 minus column 3. So that one xy into x minus y, that is the first column is now unchanged, x plus y. Second column is now 1 minus 1, y minus 1, y square minus 1, 1, 1, 1, the third column unchanged. Once again, I am writing the second column in the other way, 0, 1, x plus y. That one 1 minus 1, 0, y minus 1, y minus 1. Now y square minus 1, that means y square minus 1 square, a square minus b square, a plus b into a minus b. So y plus 1 into y minus 1. Third column remain unchanged. Okay. So once again, we can check in the second column, there is a common element, y minus 1. So we are taking it common. So that is y minus 1. First column 0, 1, x plus y. 0, 1, y plus 1. 1, 1, 1. Now look, already we have minimized the total determinant in a very short form. Okay, so here we are simply determinant in the expanded form, and expanded form is very easy. That is 0 into 1, 1, y plus 1, 1. Already I am writing, you don't have to write that. 0, 1, 1, x plus y 1, plus 1, then 1, 1, x plus y, y plus 1. Okay, so that one 0, that one 0. Simply the result is x, y, x minus y, y minus 1, and then 1 into y plus 1 minus x minus y. Okay, y is omitted. The result is just finally x, y, x minus y, y minus 1, 1 minus x, and that is the answer. That is the value of the determinant. Let's check with another one example. And that one example is the first assignment we have given, the first one. Okay, where we have the problem like 1 plus 1 or omega or something. Suppose the problem was 1 omega cube, omega square, omega cube, 1 omega, and the third row was omega square, omega 1. Find the value of the determinant. Okay, I am not saying it as W, I am saying it as omega. Okay, that's a Greek letter. In capital, omega is that sign. In small letter, omega is that sign. Okay, what is the meaning of omega? Now, omega is the cube root of 1. Already that one has been given also in the problem. So that one can be written as cube root of 1. So cube root of 1 is equal to omega. So we can say omega cube is equal to 1. That one is the first property for omega. Second one, which has been not given in the problem, that is 1 plus omega square is equal to 0. 1 plus omega square is equal to 0, which is required here, but at the last moment, not at that moment, but in the last moment. So here check, if omega cube is equal to 1. So we can write that determinant in the place of omega cube, only omega cube. We can write 1. So we are writing 1 omega square. Omega cube, so that one is 1 omega. Last one, there is no omega cube, so omega square, omega 1. Okay. Now I am expanding using the first row. So 1 into, as usual, 1 omega 1. Okay. Next one, there must be minus 1. Okay. So minus 1, and which one? That one and that one. So it is becoming 1 omega square 1. Finally, which one? Now omega square. So that is plus omega square. And which ones? That one, that one. So 1 omega square, just writing in the form of expansion of the determinant. Now as we
Sir,
proceed, bolo
মাঝখানেরটা হয়তো তো ওমেগা কিউব। ওকে স্যার, সরি স্যার, ওমেগা কিউবটাকে আপনি 1 করেছেন
already 1.
Sorry.
Omega cube already has
Sorry,
been
sorry.
taken as 1. Okay, so
Okay.
1 into 1, that means 1 minus omega square. 1 into 1 minus omega into omega, that is 1 minus omega square, minus 1 into 1, that means 1 minus omega cube. Okay, then plus omega square, 1 into omega, that means omega, minus 1 into omega square, that is omega square. Yet now, okay, so the very first one is here, that omega cube can be written as 1. So that one is becoming 1 minus 1. Okay, so that one is 0. So that portion is now 0. We can omit it. So we are writing 1 minus omega square, that means that one, plus there is given omega square. So omega square into omega, that means omega cube, minus, as there is the minus, so omega square into omega square, that means that one is becoming omega to the power 4. Okay, again next one, 1 minus omega square, omega cube, that means 1, minus omega to the power 4, that means omega into omega into omega into omega. So omega into omega into omega, that means omega cube into omega. So we can write it as omega cube into omega. So that means 1 plus 1, both are giving us 2, minus omega square, that one. Okay, and that one, omega cube means 1. So it can be written as minus omega. So yet now the result is 2 minus omega square minus omega. Now already we know what? Now 1 plus omega square is equal to 0. Okay, so omega plus omega square can be written as minus 1. Just take the left hand plus 1 into right hand, so that one is minus 1. Okay, so here we are writing 2, taking them common, minus omega square plus omega, which one? That omega plus omega square can be written as minus 1. So 2 minus of minus 1 is equal to the 3. That is the result.
স্যার
হুম
স্যার একটা কোশ্চেন আছে, বলছি যে এইটাকে আমরা রো বা কলাম ধরে করতে পারি না? মানে যেমন
করতেই পারি,
C1 is equal to C2 minus
করতেই
3
পারি,
C3 বা R1 is equal to,
করতেই পারি।
তো ওইটা একটু বলবেন ওটা কিভাবে করব?
আমি কি বললাম, এটা তো করার কোনো দরকার নেই। আমি সেই প্রবলেমে যাব যে প্রবলেমটা আমার কাছে রো কলাম অপারেশন করে করলে ইজিয়েস্ট হইতে হবে। এইখানে এই প্রবলেমটা আমি রো কলাম ধরে কেন যাব, সেখানে তো আমাকে বেশি ঘাঁটতে হবে।
হুম,
আমি তো সেই প্রবলেমে যাব না যে প্রবলেমটা আমাকে রো কলাম অপারেশন করলে বেশি প্রবলেম। আমরা ওই যে বললাম যে আমরা সেই টাইপটাই যাব যখন আমাদের অপারেশনটা দরকার, তাই এটাতে আমরা যাবই না। ওকে, আমরা আর একটা প্রবলেমে যাব, তখন সেখানে গেলে জায়গাটা বুঝতে পারবো।
ওকে ভাই, ওকে
ঠিক আছে, আমরা আর একটা চেক করা যাক তাহলে।
ওকে।
সাপোজ আর একটা, আচ্ছা বাকি কোশ্চেন আছে কারোর কিছু এখান থেকে? ওকে,
না স্যার।
চলো নেক্সট আর একটা প্রবলেম দেখা যাক, সেইটা আমরা এক্সপেনশন করে করব না রো কলাম অপারেশন ধরে করব। সাপোজ গিভেন y প্লাস জেড এক্স ওয়াই, জেড প্লাস এক্স জেড এক্স, এক্স প্লাস ওয়াই and then y z. Just find the value or prove that, practically বলেছে যে it has the value that one x plus y plus z into x minus z whole square. Now when that type of problem is given, we have to proceed according to the answer is given. We should proceed in that way. When the first column has been given, so we may think we can decompose, we may decompose, but why? Because after decomposition, that would be x y z, all would be in the different format, and moreover we are diverging from our problem. So at first we have to think what has been given according to our answer, that is x plus y plus z as it is given. So we have to think, at first we have to proceed up to x plus y plus z. Then what we can do? Now check the first column y plus z, second column x, first column z plus x, second column z or x. Okay, third column x plus y, y. So there is something which we have to proceed in the different manner. Okay, so we are here at that moment doing the first one, r1. First r1 we are doing r1 plus r2. Okay, then r2 is equal to r1 plus okay, nothing, just simply at first do r1 is equal to r1 plus r2 plus r3. Row 1 যেটা আছে, we are adding all r1 plus r2 plus r3. That means row 1 is changing now. Just check here. First y plus z, I am writing in that way, y plus z, then r2, that is z plus x, then x plus y. Okay, second column is now x plus y plus z. That means row 1 plus row 2 plus row 3. That one is also row 1 plus row 2 plus row 3. In the third column, that is also y plus x plus z. That means row 1 plus row 2 plus row 3. Now, what we are doing? The row 2 and row 3 are remaining unchanged. So x plus y, y, z. Okay. Now look at the first row. That is x plus x, that means 2x, y plus y, that means 2y, z plus z, that means 2z. So taking 2 common, we have x plus y plus z. Okay. Then x plus y plus z. Then x plus y plus z. And second row, z plus x, z, x, x plus y, y, z. Okay. So in the first row, we have a common element. That one, x plus y plus z. So that one is becoming 2, 1, 1. Z plus x, z, x, x plus y, y, z. Yet now, we should not continue with the expansion, because without expanding, we have to do that. Okay. So next one operation we are proceeding at that moment. Suppose we have to consider, for ease of the calculation, changing C1 to C1 minus C2. Okay, C1 minus C2. So it is becoming x plus y plus z. So 2 minus 1, that means 1. Z plus x minus z, that means it is x. X plus y minus y, it is becoming x. Now 1 z y, 1 x z. So all the first row elements are 1, 1, 1. So that means we can do 0 here, as like the previous one problem. Okay. So here we are changing the row 1 and row 2. Sorry, column 1 and column 2. Okay. So column 1 is now, suppose column 1 minus column 3, and column 2 is now column 2 minus column 3. In the same problem, same step, we are proceeding with the two operations. So check x plus y plus z, as column 1 is changing. Column 1 is changing, so that is 1 minus 1. I am writing for you 1 minus 1. The second one, column 1 minus column 3, so that means x minus x, and that one, column 1 minus column 3, x minus z. Okay. For the column 2, 1 minus 1, z minus x, and y minus z. Third column remaining the same, 1 x z. No problem. So what is happening? X plus y plus z, that one is becoming 0, 0, 1, 0, z minus x, x, x minus z, y minus z, and z. So at that moment, the expansion is very easy. Very easy. Just x plus y plus z, that one 0, so that one is becoming 0, 0, so that one 0. So only 1 into just that portion, 0, z minus x, x minus z, y minus z. Moreover, that is 0. So that can be written as x plus y plus z into z minus x, x minus z. Okay. But we have the calculation as x minus z whole square. But according to that, something has been wrong, because we are getting the result as x plus y plus z, that is x minus z. So minus is here, and that one x minus z whole square. So minus something is there. Which one is? Just that one.
তোমার মাইনাসের সাথে হ্যাঁ ক্যালকুলেশনটা প্লাস হবে প্লাস
that must be a minus.
হ্যাঁ কারণ এটা প্লাস তাহলে চেঞ্জ হয়ে যাবে
0 into y minus z, minus of minus, that one, minus of minus. So that one is becoming, the wrong is here. Already we are finding according to the answer. So minus is there because 0 into y minus z minus of x minus z into z minus x. So we are taking the common as like that one, minus of z minus x. So that is minus of minus, that is plus x minus z into x minus z. So that means the answer is x plus y plus z into x minus z whole square.